So today's all about solving our absolute value equations. Now, before we algebraically solve, we're going to graph this absolute value equation. Now, if I'm looking right here at this y equals the absolute value of x minus 4 with a plus 2, what are the transformations happening here? Yes, you are translating right 4 and then where? And up 2. We're translating to the right 4 and up 2. Now if we look, we're being asked to graph 3 different things here. Each one of these, 1, 2, and 3, is set equal to a different number. In order to graph this, what do you think I need to do first? Can I just immediately graph these equations? What's wrong with them? What do they now have? They're equal to a... What is each one equal to? A y? What is that? So guys, I was just looking for the word number. They're equal to a number. So this original function is just y equals and then an equation. Notice all of the numbers are on one side. And we can immediately graph this. But here, we do not have all of the numbers on one side. So what do you think we need to do? We need to move those numbers to the other side. So here, I'm going to subtract 5 to both sides. And I have x minus 4, and then what? Minus 3 equals 0. So I can now graph this. Notice, I'm still going to the right 4, but then where am I going? Down 3. And did this have a stretch or compress at all? No, so where should the next perfect point be for that? Up 1 over 1. And the mirror image on the other side, up 1 over 1. And it's going to continue in that pattern forever, upwards to the left, and forever upwards to the right. Oh. Now, on this graph, the purpose of graphing it, the purpose of us putting this on paper was to find the solutions. Do you guys remember when we're dealing with algebra, what another word for a solution to an equation is? There are 4 of them that all mean the same thing. Solution is 1. Where exactly are the solutions to this graph? Where it passes the it's an axis, where it passes the blank axis. Which axis gives me the solutions to a graph? Yes! Where it passes the x-axis. So, we have 2 solutions here. One at 1, and one where? Where's the second one? Where's our second intercept? One was at 1. Where's the second one? 7. Exactly. So I have two solutions here. X equals 1 and x equals 7. Both of these were x-intercepts. That's another word for a solution, is x-intercept. I'll just give you the other two words because I don't think you guys are in the mood to give them to me. We have roots, or they're also called zeros. All of these words mean the same thing. Solution, x-intercept, roots, or zeros. Anytime they ask for any of these, they're asking for the place where the graph touches the x-axis. So let's try it again. What do we need to do first to number 2 in order to graph it? Oscar, what do you think we need to do first here to number 2 so that we can graph it? What did we do first on number 1? Exactly. We need to subtract 2 over. So we have x minus 4, the absolute value of x minus 4. And what happens to that 2 minus 2? Because I subtracted 2 over, what happens to 2 minus 2? It cancels, giving us 0. So we just have the absolute value of x minus 4 is equal to 0. So now, has this moved up or down at all? No. Where has it moved? Where should I be graphing this? No, where's Isabella? Aiden, where is this moved? Yes, 4 to the right. So I'm just moving 4 to the right and placing my vertex. Has it been stretched or compressed? No, Elvis. Right. Kennedy, has it been stretched or compressed? No. So where's my next perfect point, you think? Up 1 over 1. And I go and do the mirror image on the other side, up 1 to the left 1. And it continues forever in this pattern, upwards to the left and upwards to the right. So, what is the solution or solutions to this absolute value? Mateo, what's the solution here? Yes, x equals 4 is our x-intercept. That's our solution to number 2. X equals 4. That's where it's touching the x-axis, so that's our solution. Ava, on number 3, what do I do first? You subtract 1. Exactly. So what color should I use? Blue. Subtract 1 from both sides. 1 minus 1 will cancel. And then I'll have absolute value of x minus 4. And then I have to do 2 minus 1. And what do I get? 2 minus 1. And what do I get? Yuri? 1 equals 0. So where has this one moved? Where should I be graphing this one? Jose. Up one and also right. How many? Yes, good. Up one and to the right 4. And it hasn't been stretched or compressed. So from that point that's now at 4, 1, I go up 1 and to the right 1 and place a point. And I go up 1 to the left 1 and place a point. Where is the solution here? Not quite. The previous one was on 4. But this one is completely above the x-axis because we moved up 1 and to the right 4. So because it's completely above the x-axis, is it touching the x-axis? No. So do I have a solution? No. So what do you think I should say? No solution. So there are 3 different outcomes we can have with absolute value. What are they? 3 different types of solution sets we can have. No solutions 1. What else? 1 solution and 2 solutions. Yes. You're always going to end up with one of these 3 situations. 2 solution, 1 solution, no solution. Most often, you're going to end up with 2 solutions. But you sometimes will end up with 1 and sometimes will end up with none. And it even explains it right down here in this note. If your absolute value is equal to a positive number, so look at number 1. Notice how it was absolute value of x minus 4 plus 2 is equal to 5. Because that 5 was a positive number, that's what made us have 2 real solutions. If your absolute value is equal to 0, look at number 2. See how our absolute value is equal to 0. If our absolute value is equal to 0, we have 1 real solution. And if our absolute value is equal to a negative, we have no real solution. If the absolute value all by itself is equal to a negative number, we're going to end up with no real solution. So let's try it. Let me see here. Which one do I want to do? I think I want to do number 3. Because then I'll have you guys do an easier one. Now, before we start solving, let's just talk about absolute value for a second. What does absolute value do? If I said, what's the absolute value of 4, what would you tell me? It's 4. And if I asked you, what's the absolute value of negative 4, what would you tell me? 4. Now, say I have an absolute value of something equal to 5. Is there one thing that could go in that absolute value to equal 5, or is there 2 things that could go in that absolute value to equal 5? 2. 1 is a positive 5, and the other is what?
Negative 5.
So the insides of our absolute value, even though they're different, end up equaling the same thing, the same 5. So when we're solving absolute value, we need to account for both the positive inside and the negative inside. Meaning we're actually having to solve two equations for each equation. So if I'm looking at number 3, which has absolute value of negative 3x plus 3 is equal to 18, negative 3x plus 3 could equal a positive 18, but what else could it be? What else could this inside of my absolute value equal? Yes, it could be negative 18 or positive 18. So once we have the absolute value all by itself, the process is to take our absolute value equation and split it into the positive version and the negative version. The positive version, I take the inside of my absolute value, 3x plus 3, and set it equal to a positive 18. Yes, Liz?
Can you repeat the equation?
So it's the absolute value of negative 3x plus 3 and absolute value equals 18. And so on our positive side, we have just 3x plus 3 equals 18, ignoring the absolute value. We're now getting rid of the absolute value. And then on the other side, we're going to set the insides, negative 3x plus 3, equal to the negative version, negative 18. This is what I like to call the split. We're splitting into positive and negative. And we're having to solve both. On the positive side, what do I do first to get x by itself? Bam. What do I do first to get x by itself? What's up? So I want to get that plus 3 to the other side. Right now it's a positive 3. Am I going to add 3? What's opposite of adding? Or what's opposite of plus 3? Oh, sorry. I can't hear you when you're not facing me. So we minus 3 over. And we have negative 3x is equal to, what's 18 minus 3? 3 gives us 15. Then what do I do? Yes, that was much better response. Thank you. Divide by negative 3 because negative 3 is being multiplied by x. Opposite of multiplication is division, telling me to divide by negative 3. The negative 3's on the x will cancel, leaving me with just x. And what is 15 divided by negative 3? Negative 5 is my first solution. Now we need to repeat this. What's my first step on the negative side? What do I do first? Subtract 3. What is negative 18 minus 3? So I have 3x equals negative 21. Good. So we need to divide both sides by negative 3 to get the negative 3 off of the x again. And I have x equals 7. And I have 2 solutions and I'm done. Just like we had 2 solutions on our graph. Because the absolute value all by itself is equal to a positive number. That should have told me right off the bat I was going to end up with 2 solutions. All right, you guys go ahead and do number 1. So in number 1, we have the absolute value of x plus 9 equals 17. What did you do first? What should you have done first here, Eli? We have the absolute value is equal to a number. What should we immediately do? and, right, exactly. So we like to do what I like to call the split. Split into the positive and negative. So we have x plus 9 is equal to a positive 17, and also x plus 9 is equal to a negative 17. And we're solving for both here. Both of these, to get the x by itself, I subtract 9 over. So on the positive side, I have 17 minus 9, which gives us how much? It gives us, Richard, what'd you get? Yes. And then on the negative side, negative 17 minus 9, what do we get? Negative 28. Thank you. I knew that as soon as I said it, I'm like, is that right? Nope. It's going off of memory. So I have two solutions here. Again, I should have known I was going to end up with 2 because the absolute value is equal to a what? Is this a positive, negatives, or 0? Positive. So positive number tells me there will be 2 solutions. Look at number 2. What is that equal to? A negative number. What should that immediately tell us? When the absolute value is equal to a negative number. No solution on number 2. When the absolute value all by itself is equal to a negative number, it's going to be above the x-axis, meaning there is no solution. All right, let's step it up a little bit. Let's see, which one do I want to do? I think I'm going to do I think I'll do number 6. And then I'll have you guys do number 5, and then I'll give you your homeworks. Number 6. What's different about this problem versus the ones that we've done so far? The absolute value is not all by itself yet. It has other numbers with it. Now, when I say absolute value all by itself, we're trying to first isolate the absolute value. That's what it's called, isolating the absolute value. Now, for some people, it's kind of hard for them to envision what I mean by this. What I like to do when I'm solving this, if I have my paper, is I cover the absolute value, all of it, that 5x plus 5, I cover it with my thumb. So pretend, don't do this, don't scribble it out, but pretend that pink area is my thumb. How would I go about getting my thumb all by itself? What do you do first here? So you're right, we do add 5, 8, yes. We add 8 to the other side, so we have negative 5, absolute value, 5x plus 5, equal to, we've now added the 8 to the other side, 17 plus 8 gives us how much? $25. Good. So then, I'm still covering up the absolute value with my thumb. Don't cross it out like I am. I'm just pretending that's my thumb. What operation is happening between the negative 5 and my thumb, or the negative 5 and the absolute value?
Multiplication.
Yes, multiplication. What is the opposite operation of multiplication? So what do I do to get the negative 5 off of my thumb, or off of the absolute value? Exactly. Yes. Divide negative 5 on both sides. So we have the absolute value of 5x plus 5 is equal to, what is 25 divided by negative 5? So a positive number divided by a negative number, I'm ending up with a negative 5. Uh-oh. What's wrong here? What do I have? What have I ended up with on accident? So, what's wrong with this? The absolute value is equal to a negative number. Thank you, Eli. It's equal to a negative number. What does that mean for us? No solution. I actually love these. Why do you think I love these? It's way less work. As soon as I see it's equal to a negative number, I know I don't have to go about solving two equations. I'm done. I just say no solution, move on. But it's only when the absolute value all by itself is equal to a negative number. That's when I can put no solution. But if it hadn't been a negative number, what would I have done next? What should I have done next? Split it. That one I heard over there. Yeah, we split it into positive and negative and solve for 2. I want you guys to go ahead and try to do number 5. So, our first step, if I was to lay out the steps of this process. Step 1, what do you think it is? What did we do first? Right. We have to isolate the absolute value. We have to get the absolute value all by itself. So that's what we're going to do first. We're going to get the absolute value all by itself. These problems are harder because the absolute value is not all by itself. So like you said, first we subtract by 8. We don't deal with the negative 5 yet. Why don't we deal with the negative 5 yet? It's being multiplied by the absolute value. Good. We need to first move the easy one. Move the addition of 8 over to the other side by opposite operation of subtracting 8. So I now have negative 5, absolute value, 9x minus 7 is equal, what is negative 2 minus 8? Negative 10. So it's equal to negative 10. Now, is the absolute value all by itself yet? No, what's still with it? Negative 5, by what operation are those joined? Multiplication. So what is opposite of multiplication? And whatever we do to one side, we're dividing by negative 5. Whatever we do to one side, we have to what? Do to the other. So I'm dividing by negative 5 on both sides. The negative 5s on the left will cancel, leaving me with absolute value of 9x minus 7. And what is negative 10 divided by negative 5? 2. So now, you may have been originally attempted to say, oh yeah, this one's going to be no solution. But once you've got the absolute value all by itself, it's not equal to a negative. It's equal to a positive 2. So how many solutions should you end up with? 2. Because it's a positive number it's equal to. So once we have the absolute value all by itself, what is our next step? What do we now do? Yes, step 2 is to split into positive and negative. So I'm going to take this, split it to have a positive 2 and a negative 2. I now ignore the absolute value, so I have 9x minus 7 is equal to a positive 2, and 9x minus 7 is equal to a negative 2. And then I need to solve both. So that's step 3. Solve for x in 2 equations. So here, I'm just going to do this really quick. I'm going to add 7 over. 2 plus 7 gives me 9. And what is my last and final step here? What do I do to get x by itself lastly? Divide by 9. So what is x here? 1. And then on the other side, I do the same process. I add 7. But what is negative 2 plus 7? 5. And then I again divide by 9. It's not a whole number. I'm going to leave this as a fraction, not as a decimal. Leave it as a fraction, 5 over 9. And I'm done. Are there any questions on this problem?